Okay, number 1. Here's your homework, 7.2. How would you graph this without a calculator? Well, this is easy. You're going to take -3, you're going to plug it in for x. So if you did 3 to the -3 power, it'd be 1 over 27. How about 3 to the -2 power? 1/9. How about 3 to the -1? 1/3. 3 to the 0? 1, 3, 9. Some of these numbers are off the page. So how do you graph this first point? Over 3, up 127. Over 2. Yeah, that's really small. And I know this is actually, probably should be closer to the x-axis, but. And I think you can get to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, you can't, you're stuck. So, if I asked you what's the domain of this, you'd say all real numbers, what's the range? Y is greater than 0. Now, I bet you, if I threw at you something crazy, like y equals 2 times 3 to the x minus 4 plus 5.
Oh my god.
How would you graph this one? What would you do? You would take this table. See, this is your parent function right here. Your y equals 3 to the x power, right? We just came up with that. How fast did we do that? What would you do to these x and y values? You guys just told me. What's the first thing you would do right here? You'd add 4 to your x values. You'd take these numbers and add 4. What would you go to next? You'd take your y values and multiply them by 2. And then what would you do? Then add 5 to those y values. So that's what you would do. So now with this one, what I would do is I would make my table of values with my 2 to the 1/5 power. So I would pretend like I'm just doing this problem right here, okay? So you probably want to write small right here, but if I put a -3 here, -3, what would you have?
125.
I heard, say it louder.
125.
125, because you'd flip it. Let's just get the parent function points. If I put a -2 here, it would be 5 squared, which is 25. If I put a -1 here, what would it be? 5. If I put a 0, what would it be? And then a 5th, 125, and 1 over 125. Okay, now, this is not my real table. What do I have to do? What does this 2 do to my y values? You would have to multiply these y values by 2. What's 125 times 2? 250. So that's, you would graph -3, 250. What's 25 times 2? What's 5 times 2? What's 1 times 2? 1/5 times 2 is 2/5. Then this is 2 25ths, and this is 2 1/25ths. So that's really what you're graphing. So over 3, Brett, you're recording, right?
Yes.
Okay. Over 3, up, that's off the page. Even that one's off the page. A little bit, right? Unless you could change your scale here. But let's just do -110. 4, 5, 6, 7, 8, 9, 10, very top. 0, 2. And check this out, 0, 2. Did that make sense to what we were talking about the other day?
Yeah.
That's your y-intercept, how about that? Over 1 up 2/5. What's happening is this thing is getting closer to the x-axis, so this is it. So I'm going to look at this table and know that you know what you're doing here. So that's not bad, is it? Graphing these? Okay, next. 3 has 4 letters, A, B, C, and D. I need you to tell me, is it linear, is it quadratic, or is it exponential? So, let's investigate. How do you go from 25 to 14?
Subtract 11.
Subtract 11? And then what's this one?
Subtract 11.
Subtract what?
11.
And then how about this? How about that? Subtract 11. So what would you say this one is? This is linear. We have one, the first common difference is the same. Okay, how about the next one, B? How do you go from 6 to 18?
Multiply by 3.
Are they all multiplying by 3? Let's
Yes.
check it out. Let's
Yeah.
make sure. Yep. So what's this? Exponential. Could you give me the equation if I asked you? So if we're gonna multiply by 3, we have to go backwards and divide by 3. So what would this be? 2. So can you give me the equation?
1 equals 2
Yeah.
times
3 to the x. Yep, that's it. Good job.
No, I was talking to myself.
All right, how about the next one? Anyone know what this one is?
I have no idea.
Would you rule out exponential?
Yeah.
Okay, this one's going down by 32. And this is 23. And this is 14. Okay, then. What is this one? Anyone know?
I have no idea.
I heard somebody saying it. It was right at the beginning, I heard him say it. What differences are the same?
Quadratic.
Nine.
Second differences are the same.
These are the same, so it's quadratic. We have a second set of differences, third 9.
The second differences are the same, it's quadratic.
How about this last one?
Everything is divided by 2.
Exponential. Why is it exponential? Or multiplying? We always think of multiplying. Yes, you're dividing by 2, but we always, when we want to write these formulas, we want to think of the multiplication process. So can anyone tell me if going this way is multiplying by 1/2, what would this be? So what would this be? 320, and this would be 0. So can anyone give me the equation? Y equals 320 times 1/2 to the x power. Okay, number 4. Number 4, 5, 6, and 7. Can you tell me what these are? Based on the equation, what would you call 4? Linear. How about 5? Quadratic, because it's x squared, right? How about 6? Exponential. And the last one is also exponential. Okay, next. Number 8. The final amount for $5,000 invested for 25 years at 10% annual interest compounded semi-annually is $57,000. Okay, what is the effect of doubling the amount invested? So if we took $5,000 and doubled it, if we double, how do you double 5,000? What do you get? $10,000. And then you're gonna do interest is compounded semi-annually, so the interest is 10%, 0.10 over 2, because we're doing semi-annually, and then 2 times how many years? 25 years. I would like for you to figure this out on your calculator. Tell me what you get. $10,000, and then parentheses, 1 plus, it's 0.1, get your fraction.
There you got a big number.
Okay, now compare that number to 57,337.
It's double.
It's double.
Wait, I'm very confused.
Wait, if you double
How
the
did
amount
I
invested,
type
just double the.
Yeah.
You get 114,674.
Or time.
If you took this number, it's doubled. So if you doubled the amount that you invested, you're doubling the money that you're gonna earn. So what is the effect of doubling the annual interest rate? So if you double the annual interest rate, so instead of it being, we're gonna take the original $5,000, and we're gonna double the interest rate. So instead of it being 10%, it's gonna be what? 20%. I just want you to do that. Now, it's still compounding in semi-annually. So 1 plus 0.20 over 2, and then it's times 2 to the 25th power. Can anyone tell me this? Are you guys getting a little bit more comfortable with this calculator?
Yes.
586,954, and that's about 10 times greater. This is approximately 10 times greater.
What did you
No?
tell me? Can I see?
I'll zoom out or zoom in. The interest rate is doubled, so it's, instead of 0.1, it's 0.2.
Oh.
And I did 2 times 25, I did that.
I see what it is.
So why?
You can go back to a brown or something to do that.
Okay, how about C? What if we doubled the investment period? So instead of 25 years, we're gonna do 50 years. 25 times 2? I heard that.
No, I didn't.
Why didn't see that?
We're doubling now the investment period. So now we're gonna take 5,000. We're still gonna go, we're gonna go back to the 10%. But we're gonna double, so instead of T being 25, doubling that is 50. So 2 times 50.
657,000.
Thank you.
Okay, did you get 600?
Yeah.
I got 657,506. Did everybody else?
Hi.
Yeah.
Okay, so question for you, last question. Which of the above has the greatest effect on the final amount of the investment?
Doubling the interest.
Doubling the investment period. Does Anyone have any questions? Okay, Ms. Burback, can you help me run around and make